Hello, second grade Smarties, and welcome to video 2 of iReady Lesson 9. So we are finding ways to model word problems. So we're going to go ahead and get started. All right, let's go for it. It says, read the problem, then you will use addition and subtraction equations to model the problem. It said, Todd plays a game. The table shows his points. Level 1, we don't know the points. Level 2, he had 16 points. Altogether, he had 55 points. How many points did Todd get in level 1? So let's read that again. It says Todd plays a game. The table shows his points. Level 1, we don't know the points. Level 2, he got 16 points. And altogether from levels 1 and 2, he had 55. How many points did he get in level 1? It says that we can picture it. You can draw a bar model. So in the bar model, it shows us that 55 is our whole. So total is the same as whole. So that's our big number. We didn't know how many he got in level 1, but we know in level 2 he got 16. It says you can use an addition equation. So level 1 would be our missing part. Level 16 is the part that we know, and we know that our whole is 55. We can also use a subtraction equation. So we can start with our whole, take away the part that we know, and find the part that we are missing. It says, look at picture it. What does the question mark mean? And the picture it, what is the question mark standing for? Look back at the table. What does it stand for? It stands for the points in level 1. What does the question mark mean? The points in level 1. Because we did not know that part, right? We didn't know how many points he got in level 1. It says, look at the second model it. Write a different subtraction equation that you could use to solve the problem. Okay, so we know that we are subtracting. And friends, this is where we start thinking about our fact family, okay? So when I have a fact family, I have the same whole for all 4 equations. I have the same parts, but I can show those parts in different ways. So when we added in this first equation, we started with the missing part. We added the part that we know, and our whole is 55. If I wanted to show a different way to model these parts and whole, what would I start with? I would start with 16 because in the first equation, I started with the question mark. So I would have 16 plus, would I put 55 here? No, because 55 is our whole. So we know that 55 is going to go right here. So 16 plus our missing part equals 55. That's half of our fact family. Then we go down to our subtraction. So when we subtract, we always start with our whole. So we always start with 55. Just like when we add, we always end our equation, and I don't want to say end, but our whole is always the biggest number, right? So 55 is our whole. The first way that we showed these parts in a subtraction problem is we started with 16. This time, what are we going to take away? Our missing part, right? So the part that we don't know, and then what will be left? The part that we do know. So in this space, we are going to write this equation from our fact family. So 55 minus the missing part equals 16. It says solve the problem from the previous page. Show your work on the open number line, then write your answer. So friends, again, if it is easier for you to do an equation like this, do that. If it's easier for you to draw 55 and take away, do that too. Find whatever strategy works best for you. So I am going to show it on the open number line, and I am going to add to find that missing part. So I'm going to start at 16. So 16, and I know my end point is going to be 55. So I am going to add groups of 10. Okay, so here's what I'm going to add. I know that in 16, I have 6 in the ones place, and in 55, I have 5 in the ones place. So I can't hop 40 because that would be 56. But what I can do is I can count up 3 more tens. So I could even do it this way. So 10 plus 16 is 26. 26 plus 10 more is 36. So see, I'm counting by groups of 10. I could just add 30, but this way I can see how my groups of 10 look like. So plus another 10 is 46. Okay, so I can't add 10 more because that would be what? It would be 56. But what I can do is I can start at 46 and count on to get to 55. So I can start at 46 and count on to 55. 46, 47, 48, 49, 50, 51, 52, 53, 54, 55. What did we add to 46 to get to 55? We added 9 more. So then I can put all of these together to find that part. So 10 plus 10 plus 10, so 10, 20, 30, and 9 more. So 39 is our missing part. I could also solve it right here. So I always start in my ones place when I see an equation. So when I start in my ones place, I do not have enough on top to take away 6. So I go over to my tens place and I ask them very nicely if they will give me a 10 to change into ones. So they give me 10 ones that I can put with 5 ones, and I will have 15. Now I can do 15 ones minus 6 ones. And how many will that be? 9. And then I hop on over to my tens place. I subtract from the 4 tens that we have. So 4 tens, taking away 1 10 would be 3 tens left over. All right, let's look at number 5. It says, talk about it. How did you make your number line in problem 4? What is another way to find the answer? So, how did Miss Mason, or you, maybe you did the same thing as Miss Mason, how did we show our work on our number line? We added on tens and ones until we added on tens and ones. Ooh, hold on. I'm going to change that. To get to our whole. Okay, so we added on tens and ones to get to our whole. The jumps made the part that was missing, made the missing part. So all those jumps that we took we started at 16, we made those groups of 10. We jumped 10, and then we added 9 ones. Adding those jumps made that missing part. The jumps made the missing part. All right. It says try another problem. Matt had 72 sports cards. Then he got more cards. Now he has 90 cards. How many more cards did Matt get? show your work. And it's a word problem, so I'm going to read it again. All right, it says Matt had 72 sports cards. Then he got more cards. Now he has 90 cards. How many more cards did Matt get? So, friends, this is really important that we underline those important words, because what we might try to do is, it's saying that we are getting more cards. So if we are getting more, that usually means that we add or we compare who has more than the other. But for this problem, we know that Matt starts out with 72 cards. He gets more cards. Does it tell us how many more cards he gets? No, so I'm going to put a question mark here. Now he has 90 cards. So what is his whole? 90. How many more cards did Matt get? So we know the part that we start with is 72. We have our missing part, but all together there are 90. Friends, remember, anytime that we have a fact family, we can show an addition problem and a subtraction problem. So using my parts and my whole, I can make a subtraction problem. So when I subtract, I start with my whole. What was my whole? 90 is my whole. The part that I know is 72. And the part that we do not know is our question mark. And this question mark stands for the cards that Matt also got. So here's what I'm going to do. I am going to draw my tens and ones. So I am going to actually make an addition. I'm going to add 72, so 7 tens. So 1, 2, 3, 4, 5, 6, 7, and 2 ones. And I know that all together I am making 90. So I am going to add on to my ones first. So 72 plus a missing part. I know I'm making 90, but I noticed that 90 has 0 ones. So am I going to have any ones in the ones place when I am finished? I should not, because I will have enough ones to make a 10. But here is what I'm going to do. So I am going to add 110, because 72 plus 110, that makes 82. And now I'm going to count on my ones. 82, 83, 84, 80, 85, 86, 87, 88, 89, 90. So in my red, how many tens did I add? I added 110. And how many ones? 1, 2, 3, 4, 5, 6, 7, 8 ones. And all together, this turns into a group of 10. I move this over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 tens, which is the same as 90. So what was our missing part? How many more did Matt get? He got 18 more cards. So I'm going to write 18 more cards. And friends, remember, you can use whatever strategy works best for you. So Miss Mason drew her tens and ones. I also could have solved it as a subtraction equation. So I could have started with 90, because 90 is my whole. I could take away the part that I know to find the part that I don't know. So I could start in my ones place. Well, I don't have enough ones in 90 to take away 2 ones. So I kindly go over to my tens and I borrow a 10. I ask them if they can give me a 10 to turn into ones. So they give me a 10. And of course, it's in the ones place. So it becomes 10 ones. And now I have 8 tens left in the tens place. Now I go back over to my ones and I have 10 ones and I'm going to take away 2. Well, I don't like to encourage this, but if I need to solve this super fast, I have 10 fingers. I can take away 2 and I will have 8 ones left. Then I hop over to my tens place and I don't forget that I'm subtracting from what was left from when we borrowed. So 8 tens are left. I'm taking away 7. 8 minus 7 is 110. So we had 110 and 8 ones. That is how many more cards Matt got. All right, Smarties, as always, keep that growth mindset. Good learners do hard things, and I'll see you tomorrow with another video lesson. Happy learning, guys.